Welcome to another episode of Mastering Cybersecurity, developed by baremetalcyber.com. Let's dive in. Multi-cloud means running applications and storing data across more than one cloud service provider rather than concentrating everything in a single environment. Organizations choose this path for resilience, cost flexibility, specialized services, or because separate teams acquire different platforms over time. The security challenge emerges when each provider exposes different control surfaces, different terminology, and different default settings that can drift apart quickly. A strong approach begins with a clear inventory, a disciplined identity model, and guardrails that express intent consistently across environments. The goal is not forcing identical tools everywhere, but achieving equivalent outcomes that can be verified and improved over time. The following guidance builds a beginner-friendly foundation that turns scattered controls into a coherent security program. Identity and Access Management, IAM, becomes the control plane that spans providers because every action ultimately ties to an identity. A pragmatic pattern uses single sign-on, SSO, with federation to centralize authentication while expressing least privilege authorization as roles within each cloud. Multi-factor authentication, MFA, should gate administrative access and break glass accounts, which are emergency identities with tightly monitored usage. Role-based access control, RBAC, works best when roles are task-based rather than person-based, which keeps permissions predictable during staffing changes. Periodic access reviews confirm that group memberships and role assignments still match actual duties and revoke anything unnecessary. Strong identity hygiene prevents credential sprawl, reduces keys left in code, and makes investigations more reliable. Network architecture remains important because multi-cloud traffic often crosses public boundaries unless designed carefully. A virtual private cloud, VPC, or its equivalent should segment workloads by environment and sensitivity with tightly controlled routes between segments. Private connectivity options reduce exposure by keeping service-to-service traffic off the public internet whenever feasible, while egress routing ensures only approved paths leave a given segment. Zero-trust principles apply across providers by authenticating and authorizing every connection based on device posture, user identity, and requested resource. Peering and transitive routing can surprise teams when implicit paths accidentally expose management services or data stores. Clear diagrams, explicit firewall rules, and periodic path testing help catch those issues before attackers find them. Data protection depends on encrypting information in transit and at rest with keys that the organization can govern confidently. A key management service, KMS, offers managed cryptography, while a hardware security module, HSM, provides tamper-resistant protection for the most sensitive keys. Customer-managed keys, CMK, allow consistent rotation policies, separation of duties, and revocation procedures that work similarly across providers. Labels and data classification guide which data sets require additional controls, such as stricter residency, dedicated HSM usage, or enhanced access approvals. Backups must inherit the same encryption and residency rules as primary data to avoid silent policy violations. Documenting ownership boundaries for keys and data prevents confusion during incident response and compliance reviews. Secrets management keeps credentials, tokens, and certificates out of source code and container images, where they are easily leaked. Centralized vault tools provide controlled retrieval, auditing, and rotation, while cloud-native secret stores integrate tightly with platform services. The best design chooses one pattern as the primary source of truth and documents when the other pattern is acceptable for local integrations. Scope secrets with least privilege, bind them to identities or workloads, and rotate them automatically when possible. Build pipelines should scan for exposed secrets and fail safely when something sensitive appears in repositories or artifacts. Treat secrets as high-value assets by monitoring access patterns and alerting on unusual retrievals, creation bursts, or policy changes. Workload hardening focuses on giving every compute option a secure and repeatable baseline across providers. Virtual machines benefit from golden images that include required agents, logging settings, and patched components updated through a reliable pipeline. Managed services and serverless functions still need configuration baselines for logging, identity scopes, and network exposure because defaults vary widely. Center for Internet Security, CIS, benchmarks offer prescriptive starting points, but teams should tailor controls to application needs and risk appetite. Drift detection catches baseline deviations created by manual fixes and urgent changes during incidents, which keeps environments trustworthy over time. Consistent baselines reduce surprises during audits and simplify troubleshooting during outages and investigations. Containers and orchestration platforms introduce speed and density, which requires strong guardrails to remain safe at scale. Admission policies validate configurations before deployment, blocking images without required labels, signatures, or vulnerability attestations. Least privilege runtime limits capabilities like host networking and privileged modes, which reduces blast radius if a container is compromised. Image signing ties artifacts to a build system and a specific source repository, which strengthens supply chain trust. Cluster isolation separates development, testing, and production into distinct control planes with independent credentials and quotas. Kubernetes governance improves further with network policies, secrets integration, and regular upgrades that address security patches without long delays. Cloud Security Posture Management, CSPM, brings continuous visibility by checking configurations against policy and reporting drift quickly. Policy as Code, PAC, expresses these rules in version-controlled files reviewed like any other change, which reduces ambiguity and speeds collaboration. Infrastructure as Code, IAC, scanning catches misconfigurations before deployment, which is cheaper and safer than chasing them afterward. Tagging standards help every resource carry ownership, environment, and sensitivity metadata, which improves search, reporting, and automated enforcement. Consistency matters more than perfection because equivalent controls are often implemented with different provider features. Over time, posture data informs which guardrails prevent incidents most effectively and deserve deeper automation. Centralized logging and monitoring unify provider events so detections tell a single coherent story. Security Information and Event Management, SIEM, platforms or equivalent pipelines normalize identity, network, and application logs into common fields for correlation. High-value detections include impossible travel for administrators, mass role changes, policy relaxations on storage, and creation of public endpoints in sensitive projects. Alert tuning reduces noise by suppressing known benign patterns while preserving sharp visibility for true anomalies and privilege escalations. Coverage improves when teams confirm that control plane, data plane, and workload logs are all ingested with correct timestamps and context. Reliable monitoring shortens investigation time and supports accurate post-incident findings. Incident response, IR, across providers when roles, tools, and steps are pre-agreed and repeatedly practiced. Access brokering ensures responders can assume time-bound roles without sharing long-lived credentials that linger after incidents end. Snapshotting resources preserves volatile evidence while services continue running, and forensic procedures keep chain of custody intact for later analysis. Credential revocation has to include cloud accounts, tokens, build systems, and secrets engines, so compromised access cannot quietly return. Playbooks should name containment paths for common attack types and identify the teams who approve risky actions like traffic blocks. Post-incident reviews turn the narrative into concrete control fixes that close the original gaps. Compliance and data residency expectations remain present even when workloads span multiple jurisdictions and providers. Residency describes where data is stored and processed, which can change as services replicate across regions for availability. Mapping frameworks to provider controls clarifies which platform features satisfy encryption, logging, retention, and access requirements without heavy customization. Backup locations must respect the same boundaries because restored data can otherwise violate policy immediately after recovery. Key locations also matter because residency promises can fail when decryption keys live in different countries or under different authorities. Clear records of processing and data classification help auditors understand intent while verifying that technical settings match written commitments. Governance, cost, and risk management hold multi-cloud programs together when tools and teams evolve. Guardrails at the account and project level define mandatory controls for new environments so every workload starts secure by default. Budgets and egress considerations shape architecture choices since cross-cloud traffic can become expensive and unpredictable without constraints. Shadow IT often appears when teams create untracked projects or subscriptions, which discovery scans and centralized billing reviews can reduce. A pragmatic exception process lets teams request temporary deviations with expiration dates, documented mitigations, and clear ownership. Transparent governance turns security into a predictable partner rather than a last-minute blocker during delivery. Central security organizations succeed by teaching patterns while allowing service teams to choose specific implementations. The pattern library might describe how an SSO federated administrator should request time-bound access, how an IaaS network should segment staging and production, and how a CMK rotation should be approved and recorded. Service teams then apply those patterns using native provider services that meet their performance and delivery needs. Regular design reviews keep patterns current as providers release new features that make strong defaults easier to achieve. Security champions within product teams amplify adoption by sharing working examples and common pitfalls. This cooperation produces consistency without forcing every team to use identical tools. Measurement keeps the program honest by showing whether guardrails actually reduce risk and operational toil. Useful measures include the percentage of resources deployed through IAC, the time to revoke privileged access, and the rate of policy exceptions that expire on schedule. Posture findings should trend toward faster remediation with fewer repeats, which indicates patterns are understandable and discoverable. Detections should produce fewer false positives while catching privilege misuse and data exposure earlier in the kill chain. Cost signals matter too, because expensive architectures often encourage shortcuts that degrade security over time. Measured improvement turns multi-cloud security from a one-time project into a sustainable capability. A clear roadmap translates strategy into weekly actions that improve real systems. Early steps usually include enabling organization-wide MFA, turning on centralized logging across providers, and tagging resources with ownership and environment metadata. Next steps extend identity federation to more roles, move ad hoc changes into IAC pipelines, and define the first policy as code guardrails for critical services. Later steps unify key management practices, adopt image signing, and introduce admission controls that enforce deployment hygiene. Throughout, small wins should be documented as reusable patterns that other teams can copy without lengthy debates. Progress compounds when improvements are easy to apply and simple to verify. Documentation connects intentions to evidence, which matters during audits and after incidents. Security standards should describe the minimum controls for identities, networks, data, workloads, and monitoring across providers using consistent, provider-neutral language. Procedures should explain who performs each step, which tools are used, where approvals are recorded, and how artifacts like screenshots, logs, and tickets are stored. Architecture decision records capture why a particular provider feature was chosen and what alternatives were considered, which helps future reviewers understand context. Runbooks then reference those standards so responders can act quickly without guessing policy boundaries under stress. Clear documentation reduces rework, speeds onboarding, and stabilizes expectations between security and delivery teams. Vendor and tool selection improves when teams start with outcomes rather than features, because every provider ships compelling dashboards that overlap in confusing ways. Centralized platforms should be evaluated on their ability to normalize identities, logs, and policy expressions without hiding provider-specific details that are essential during investigations. Native tools should be preferred when they meet required outcomes with less complexity, while third-party tools can bridge gaps where parity is not available. Procurement should consider export paths for data and policies to prevent lock-in that frustrates future changes. Integrations must be tested with failure scenarios such as outages, revoked tokens, and permission errors. Tooling succeeds when it makes correct behavior the easiest behavior for busy teams. In summary, multi-cloud security becomes manageable when foundations are built deliberately and improved steadily. The program starts by discovering assets, clarifying responsibilities, and making identity the unifying control plane across environments. It strengthens by encoding intent into repeatable guardrails, verifying behavior through posture checks and logging, and practicing response with clear playbooks. It matures by measuring outcomes, simplifying tool choices, and documenting decisions so improvements persist through team changes. With inventory first, identity-centered, standardized guardrails, continuous verification, and measured improvement, the complexity of multiple providers turns into dependable security discipline. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.